Thank you very much, Alex. And well, Stuart, we had apparently some problems. His voice was lost and he didn't notice. But anyway, so welcome to this first session for the Data Platform Discovery Day for the U edition, and I'm going to talk about SQL Titbits for the Inexperienced. So let's see here if I can just my keyboard work. That's right. Sorry. So I like to give idea of how this presentation came about is that I answer a lot of questions in the SQL forums, and I noticed that there are some things that come up again and again and again. And I would guess many of these people are people who have used SQL for quite a short time, maybe a year or two, but not really. It has not been the prime focus, but rather it has been sort of doing it left-handedly. And there are some, and I would say also mainly the things I will bring up here are more for developers than business users. Not that I don't like business users, but I will make some connections to other languages that developers might recognize. Oh, wait a minute, okay, which business users may not have the same idea of. Anyway, so I do see these questions, mistakes, and misconceptions, and I've taken some of these, because I could basically talk about the whole full day about all these things and put it into these sessions. So the first things I would take up are really basic, and some people might say, "Oh, I know that already." But the later tidbits will be a little more advanced, still now with the realm of the novice user. And the way also that the tidbits work is I will start with a demo and then sum them up on the slides. So I will basically talk about to the SQL scripts and then just do a summary on the slides. So first, also a little bit about me. My name is Erland Sommarskog. I live in Stockholm, where I work as an independent consultant. I've been an MVP for SQL Server for many years. I have a website, sommarskog.se, which you can say is a small collection of large articles that goes in depth in a couple of topics. For example, I got one long article on dynamic SQL, something I'm not going to talk about today, but I believe it's a fairly popular one. And also there is my email address. So if after this session think, what to make, I would like to know more about that, please feel free to mail me at sql.sommarskog.se. Slides and scripts, they are available on my website, sommarskog.se/present. I will just stop a short while so you can take a note of that if you want to. So you can download all the slides and scripts afterwards. Okay, so these are the tidbits I would talk about. Go is not an SQL statement. I would talk about the null and the not in trap. I would talk a little bit about data types in SQL Server. I would talk about union and union all, CTE and derived tables, things that I know that developers often people have been using SQL well for a while. What is this? What is that the magic? And also about temp table and table variables. So Go is not an SQL statement. What do I mean by that? So I got a script here in Management Studio, and you may notice here that I actually got the same piece of code twice. You may also note that all statements here, all lines end with a semicolon, except for this one that says Go. So in SQL, or in standard SQL, the semicolon is mandatory to terminate a statement. In transactive SQL, the dialect we use in SQL Server, this is not the case for historic reason, because originally when Sybase designed TSQL, they thought that semicolons, hey, that's for webs, so they did not even permit them. And now they are optional, but it's actually deprecated not to use semicolons. But still, this line there does not have a semicolon. Why? Well, this is because this is not an SQL statement. This is an instruction to Management Studio. So when I press execute, look here what happens. First of all, look at the text. It does produce a result set and then waits for 2 seconds. So when I run this, well, nothing happens for 2 seconds. Now I got that date. And again, there's a delay of 2 seconds. What actually happened was this. Management Studio took this piece of code, sent that to SQL Server, who executed it. And then when Management Studio had gotten the result set, had gotten the feedback that SQL Server was done, it sent the next thing. Now, Go for Management Studio has to be Go on a single line. It can be followed by a number or some spaces, but I'm not going to talk about that. But if I add a semicolon, Management Studio no longer thinks that this is a separator, so it will send everything to SQL Server. And this happens. I get incorrect syntax near Go, because for SQL Server, Go is just, well, it doesn't fit in with the syntax. And also I get this error. The variable name D has already been declared. And if I commented out the Go, to make it even clearer that it's definitely one single batch, I still get that error, because now Management Studio sees, SQL Server sees everything at once, and that's why it is an error. And if I do, I can change the name of the variable, look again, now what happens? And again, there is a delay. It's a longer delay than the previous time, but now I've got both dates coming at the same time. And the reason that there is a delay with the dates being displayed, although the select comes first, is that the output is buffered. So to summarize, Go, it's not an SQL statement, it's a batch separator. And it's nothing unique to Management Studio. About every query tool that has ever been written to work with SQL Server has used this convention. And Go is never seen by SQL Server because the query tool takes the script, splits it up in batches, and sends them one by one. And first sends the first batch, SQL Server sends the response, then the query tool sends the next batch, and so on. I've also got animation to just show what happens here, just to illustrate the point. So Management Studio sends this, SQL Server produces the results, then sends it after the delay, gets the next batch, and so on, and then it's done. A few more notes about Go. So Go is something that query tools use, but it's not understood by client API. So if you write a program in C# or in Java or whatever that reads the script that you have with Go in, well, then you will need to pass out the Go yourself, which is quite simple because it's Go on a single line. Well, if you want to handle if Go is in a comment or in a string, it's a little more complicated, but often you don't have to do that. Management Studio does that, but earlier tools did not do that. Also, there are some statements that has to be in a batch of their own, and these are the important ones: create procedure, create function, create view, create trigger. You can't say print, I'm creating my procedure, immediately followed by create procedure. Then you will get a syntax error. And also, because it is a batch of their own, this means that if there is a Go, that is the end of the stored procedure. I sometimes see fortunate people in the forums who have, well, they've written a procedure, but they're confused because they put in a Go right in the middle of what they intended to be a stored procedure. But it was only the text up to the Go that was the procedure. Now I'm going to move on to talk about null values. This is also one thing that quite naturally confuses people who are new to SQL because it is a very different thing from what we have seen in other environments. It's quite unique to SQL. So I got a demo database here called SQL Titbits, which is just a collection of small random tables. I got a customers table here, and you can see here I got, well, customer name, street address, zip code, city and country, and there is also a cost price by ID column, and a few more that I'm not going to use. But in the cost price by ID column, we can see what some of them have a value and some of them have null. Now, the natural interpretation for a human when we see this is that this guy on line 4, his name is Gustavo Mazzetti, he does not have a custom responsible. There's no one responsible for it. But that is not really, however, the sort of basic idea in SQL, which I'm going to illustrate now. Because let's say now I'm new to SQL and I want to find the customers who don't have any custom responsible. So I say select star from db customers where customer by d equals null. It is very natural to write this. However, when I run this, I get no rows back, despite the fact we saw there were rows with null values. And then I might get desperate, so I try select star from db customers where customer by d is different from null, and I still get no rows back. The reason for this is that null in SQL, it's an unknown value. So the idea is that we're comparing, let's say, 5 to null. Well, that null could be 5 by pure chance. It could also be 47 or 85 or maybe a string value. We don't know. It's an unknown value. So therefore, SQL has a 3-value logic. There's not only true and false, there is also unknown. And when you do a filtering of like a where clause, well, the condition must be true. And unknown is not good enough. So how do we find the null values then? Well, thankfully, SQL has special operators for that. So rather than say that equals null, which has 3 possible values, true, false, and unknown, we use is null, which is, well, Boolean, true or false. Now, when I run this, I get them back. There was 6 of them. And I can say is not null to find the one that has custom responsibles, and there are 14 of them. And I like just to stress this point a little further. It's no different if we use a variable instead and use equals, I still get no rows back. Or if I would do some kind of a join, so here I'm thinking that I would want to see the customers who have, well, 4 or 7 as the customer responsible, or none at all. But the join condition will not include the one with null because that condition evolves to unknown. So yes, null represents an unknown value, and SQL has three truth values: true, false, and unknown. This is something that might take some time to wrap your head around, but well, you get used to it by time. The more and more you work with SQL, believe me, it happened to me. All of these operations like equals, not equals, greater than, etc., they will yield unknown if you evolve the null value, because the idea is that, well, the null may or may not be the same as the value we are comparing to, and it's unknown. We don't know. But in real life, we often use null to mean something specific, like, well, in this case, there is no customer responsible. An end date means, well, it goes on, there is no known stop date, or it has other special outer band value. Sometimes there is a great debate, should you have nulls at all? I think null is a great thing because we often need these outer band values. And where or on, well, when you do a filter, it will only include the condition in a row if the condition is true. And you need to use is null and is not null to check for null value in the column or variable. Here is also the truth table for SQL, which is longer than the usual one, because since there are three possible values, the first four rows are the ones we know well of from all other environments. But if we then go down here, well, we have the combination of false and unknown. And if we take false and unknown, well, that is still false, because if we have an and, well, and one leg is false, then the expression must be false. But false or unknown, well, we don't know. It could be true, it could be false, because it's unknown. On the other hand, if we combine true and unknown, well, true and unknown, well, this one is true, but this one we don't know, so it's still unknown. Whereas true or unknown, that yields true. And if we have unknown on both sides, of course, both and or will yield unknown. And not unknown, well, it's still unknown. And this truth table, we're going to use this in the next tidbit here, the not in trap. And I will tell you, this is something that about everyone who's worked with SQL, it's probably a mistake that they have made some point in their career. I don't remember if it happened to me, but I'm quite sure that it did. You might be, if you actually haven't done this and you remember this from this session, you might be the lucky few who did not. So in my tidbits database, I actually got a table with my customer responsibles. There's 9 persons of them. And then I can run query like, okay, I want to find the customer responsibles who are located in the same city as a customer. So I can run this select star from db customer responsibles, relocation in select city from db customers. I would expect most of you have run queries like this, because this is fairly straightforward to write. And you see there's three of them. And then, okay, I want to find the customer responsibles who are not located in the city where there is a customer. And I can run this. Also comes out quite naturally. That's 6 of them. I just put it not there. Okay, then I can say, okay, I want to find the customer responsibles who are responsible for a customer. So I say select star from db customer responsibles, cost press by d, where select in cost press by d from db customers. And it comes out 7. So okay, then I want to find the customer responsible who have not yet been assigned a customer. So I expect this one to work. But I'm in for a surprise because I get no rows back. Why did this happen? Well, let's have a look at what this query, the subquery returns. And I'm going to add a distinct to make it easier. So I get back, you see, 1, 2, 3, 4, 6, 1, 2, 3, 4, 6, 7, 9, and null. So this is actually the same thing. We can take this the value and put it here and say it's just an in, 1, 2, 3, 4, 5, null, and then I just move the not outside. And this in here, this is actually just a shortcut for cost press by d equals 1, or cost press by d equals 2, or blah, 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 etc. Cost press by d equal null. So, okay, then if, let's say we're looking at evaluating this for cost press by d 5. Well, 5 is not equal to 1, it's not equal to 2, etc. So it's false, or false, or false, or false, or unknown. But remember that truth table. False or unknown, that yields unknown. Not unknown yields unknown. So this does not yield true. We do not get the row back. So this is the trap. If you use not in and there is a single null value in this query that you're using coming back, it doesn't help if there are 1 in a million rows with not null values. With one single null value, the query will not return any rows at all. So that's a quite easy, simple workaround for this, or to address this. I can use simply in my subquery filter out the null values. So I just say where customer specified ID is not null. So then I get back my 2. And while this is a solution, and it's is one you may want to use, definitely nothing wrong with it, I would say there is a better way to do this, because there is the exists operator or not exists. And this might be something you haven't seen yet in your SQL career, but believe me, this is something you will use, and you should definitely, if you haven't seen this before, you should start to play with it and learn to using it. So what does this means is that in this case, since I got not exist, means that I got this subquery is evaluated for every row in the outer table. Logically, how it happens physically, that is up to the optimizer. But logically, it's evaluated for every row. And if this query does not return any row, well, then we will return this row from the outer table. And then I have 5 and 8. So it exists here. And also, this is a binary operator, true or false. There is no unknown here because we know whether we get back rows or not. And we can also use exists for the same purpose. So here, this returns true if there is a customer with this cost specified ID. This query is evaluated for every row. And you see, I get back 9. Sorry, 7. And you may think, and as I pointed out again, the optimizer is figuring out how to do this. As a matter of fact, this might seem slow, evaluating for every row, but this query and this one up here, my experience, the query plan is exactly the same. It's implemented in exactly the same way. There's also another advantage with exists I like to call out, and that is the fact that, well, let's say we have a multi-column conditions. I want to find the customer responsibles who are located in the same city as a customer they are responsible for. Now, that can be difficult to do within. I don't even know how to do it within, but with exists, it's very simple because exists permits you to include many conditions at the same time. So I can run this query. So exists is a really great thing, but I also don't appreciate the fact that if you're new to SQL, the using in here is very simple because you're sort of just taking existing queries and composing them on top of each other. That's easy to do. It does take some time to wrap your head around how this exists things work. I seem to recall that from my young days with SQL. But still, you should explore this. I like to call on one trap, mistake I sometimes see people doing with exists, because almost always, or rather, the subquery should always be correlated to the outer query in some way. So this one is very strange. It says dbuilder customer responsibles from exist. Well, select star from dbuilder customers where the city is Stockholm. And this query, well, it will return either all customer responsibles or none at all depending whether there is a customer in Stockholm or not. In this case, there is one, so we get back 9. But that's if it sounds like an odd query, well, it is. So if you do exist, keep in mind you should always correlate it to the outer table, or the outer tables in the rest of the query. So to summarize what I've talked about, if you run this type of query with not in, and this subquery returns a single null value, you will not get any rows back because that null value may or may not be equal to the value you're comparing it to. That's how SQL looks at things. Instead, use exists, and this subquery will not exist or exist. It's logically evaluated for every row in the outer table, and it will return true or false depending on whether there are in the rows, but never unknown. It's also great for multi-column conditions, so it's a lot more scalable to do more complex queries. So it's really great to learn this. And keep in mind that the where clause for the exists query should always have at least one condition to the outer query. If you don't have this, you've probably done something wrong. Okay, now I will move on to talk about data types. And this is a quite broad topic, even for beginners, and I could probably do a full sessions only about data types. But I will just bring up a few things that are really dear to me, and I see often confuse people. And of course, well, for good reasons, because they are not, they're certainly not intuitive the way things work. They are. Well, anyway, so I got this table called file data here, and I got an ID, I got a name, I got an integer and a string. But the thing is, I'm reading this from a file, from the source. I got an ID, a name, an integer, and a date. But I'm reading this from a source that is known to mangle the data every once in a while. So I need to read the integer and the date as strings. then do some validations on them, and then, well, put the bad rows into some error table, and then load the good values into real table. This is quite a common scenario in a process known as ETL to do this sort of thing. So I got this table here, and you see I have 3 rows of the table, and there are, all of them are good. Those are integers, those are good dates. So I can then, if I think this, I can run this query. And depending from where you come from, you may or may not think that this query is good or not. If you only work with, let's say, strongly typed languages like C#, Java, etc. You might, wait a minute, this is wrong. We are comparing string to a number. That should not be able to pass, because in most languages, that's an error. But you can see I can run this query. And of course, if you come from Python, you think this is, what's wrong with this? This is perfect and normal. But you see, I got back my row. And here I'm comparing my date string to my date. And that also works fine. Okay, so then I'm going to add 2 more rows to this table. But you can see this time, well, I got a mathematical number, because it's apparently a hex number, 12BOAF. And this one, well, the date. Now, there wasn't 30 days in February last year, was it? Don't think so. And now I'm going to run my queries again. Oh, certainly got an error. Conversion failed. We converted the varchar value 12BOAF to data type int. And try this one. Conversion failed. We're converting the date and/or time from character to string. So why did this happen? Well, so this is the story. SQL is like C#, Java, etc. It's a statically typed language, but it has more implicit conversion than most other languages. So yes, there is implicit conversion between strings and numbers, also between dates and strings, etc. Not between integers and dates, but between integer and date times, just to confuse. SQL, particularly SQL, is very confusing at times. Anyway, so how does this conversion, in which order, where did it take place? Apparently the string was, SQL Server tried to convert the string to a number. And why did it do that? Well, so SQL maintains a precedence list. So when 2 types meet, so the types are ordered in the precedence list. The type with lower precedence will be converted to the one with higher. And string is low on that list. So if string and a number meets, the string will be converted to a number. Same thing if a string and a date meets, the date has higher precedence. So to address these and to find the values, well, I could use the correct data types. So now here I got 4, 6, 7 in quotes. I'd like to call out for some people who are not aware of this that these are 2 different things. You can tell this one is black, this one is red. And if you would look at the bit patterns inside the computer, they're very, very different. So now I'm looking for the string 467. There's no data type conversion. I get my value back. The same here, I'm converting the date to a string. And because it's a date, I need to use the right format to match my string. And I get back the date. Now, matching the format can be a little bit tricky. What if, for example, there are leading spaces when I'm looking for this value? And I don't care about it. Well, there is also another alternative. I can use the try convert. I make an explicit conversion. And there's 2 ways. There's the convert and try convert. There's also cast and try cast. So they are convert and cast are the same thing. Convert is just the old way, and the cast is the answer standard. But try, if you use only convert or cast, you will get an error if conversion fails. With try convert or try cast, you get a null value back. So you don't get the error message. So I can do this. I'm making conversion to the number value, but I get back my row. And the same thing for the date. So yes, SQL is a statically typed language, but it has more implicit conversions than in other languages. I don't like this, but I believe this is the SQL standard. I don't like this thing that strings and numbers have implicit conversion. But so that sort of hides the fact, but it is statically typed. It's quite important to understand. And to sort out with these implicit conversions, SQL Server has a strict data type precedence list. So when 2 types meets in an expression, well, SQL Server will then cast the type with a lower precedence to the type with a higher, or attempt to cast. If there is an implicit conversion, I did not include an example of this, but really odd for things like, well, if you try to convert an integer to a date, that will not work out. You will get a compilation error, or something really weird like unique identifier to an integer. Doesn't make sense. But there are so many implicit conversions that you can work it for a long time without running into an explicit compilation. And here is the simplified precedence list. So strings are always numbers, then date and time. And that's sort of all you need to know. But if you're curious, I have the full precedence list here for your reference in the deck. I'm not going to talk about it. I like to also call this out when we are comparing strings. We get this, and this is not only comparisons, it's all sorts of combinations. If we have, well, let's say if you use the plus operator for, can either be plus or it can be concatenation, will have the same effect. But the gist here is if we are comparing a string column to another data type, because string is low on the list, we will almost always get an error at some point. Maybe we get away with it initially, but at some point there will be something in the string that does not convert. So, and keep this in mind, that 467 with and without quotes are really, really different for the computer. I like to call that out. So the way to work around this is convert number of date variables to string explicitly to make the comparison, or use try convert to avoid the errors. But just comparing a string to some other data type is likely to go bad at some point. Now I'm going to move on to talk about union queries. Union is an operator that permits us to combine the result sets of several queries into single result set. And it has some interesting aspects. So first of all, I'm going to create two tables here, two temp tables, one called alpha, hash alpha, with column in, and I'm going to add 1, 2, 3 to that table. And then I create a temp table called at beta or hash beta with a column m, and I insert the values 3, 4, and 5. And then I run this query here, select n from alpha, union select n from beta. So I will get back the combined result set of these two. Almost. Look here what happens with the number 3. It goes away. And also, first of all, let's talk about the number n. That's the column name from alpha. So the column name for the resulting query is always taken from the first query. But why did this 3 disappear? Why does it not appear twice? Well, union is a set operator. And overall, the relational databases are based on set theory. And in the set, a value can only appear once. So therefore, the duplicate in the intersection between these two is removed, and we only get back the actual distinct values in the set. And then I'm going to add a few more values to alpha. I'm going to add 12 3 times, and to beta, I'm going to add 15 2 times. So I got some duplicates in the sets themselves. And I'll run a union query again. And you see here, I get back, 12 and 15 only once. So union is not only removing the duplicates in the intersection, it's also removing the duplicates in the individual tables. Now, there is a variant of union called union all that works differently. If I do this, you can see I get back all values. It does not remove the duplicates. You may also note here that I add an order by n, and it is n, although this one column is called m, because the order by, although I'm combining several queries, I said, but the order by always applies to the final total union query. I can't have an order by here. That would be a syntax error. Now, here's a very interesting observation. So we don't actually use relational databases much to solve problems with set theory. We use relational databases to work with our data. And when we do that, actually most of the time, the union operator is very powerful, but we don't want union to spending time on removing those duplicates. Either because we actually want these duplicates for one reason or another, or we know already there will not be any duplicates because we know already that the sets are distinct. And removing duplicates, that takes resources, because then the SQL Server needs to sort the value or apply some other mechanism to get rid of these duplicates. So I'm saying this, 95% of the time, or maybe even more, union all is what you want. You don't want any duplicates to be removed. Therefore, the few situations where you actually want this, I think rather than writing this one, when I see this, so is the program aware of that union remove duplicates, or does it really want the duplicates to be removed? I think it's a lot better to do this, because I can write a subquery here, and I will talk about this concept of derived table a little bit more later. But I can do this, say from having this query, and then union all, and then say select distinct on the outside to make it clear that this is what I want. Now again, I get back the distinct values, but now I've made it very clear for anyone who's reading my code. Yes, I want the distinct values. So let's look at this a little more. I've got two tables, new tables here called East transactions and West transactions. So let's take a look at these. And well, they look very similar. There's a transaction ID, there's a name, there's a quantity, and a transaction date. Now, East transaction is from East Bank, and West transaction is from West Bank. So these transaction IDs, they are actually completely uncorrelated. They have no relation to each other. They just happen to be. It just happens to be the case that Tina has transaction 2 on the same date with the same quantity. That's just a pure chance. So if I run this query with union, I only get back 9 rows because union removed this duplicate. But was that really what I wanted? Probably I really wanted to see this. I wanted to see all transactions, because why would I just remove this by chance duplicate? Although, of course, in real life, I would probably add something that tells me which bank was the transaction in. And in this case, well, I had union all, it would not make the difference because of these East and West. I know that the sets are distinct. But let's see the other queries I could run. Let's say I want to see who did transactions on which date. Well, for this query, it maybe makes kind of sense that I want to see just this. I don't really care how many transactions they did. I only know who did transactions on which date. But again, it's a lot better to do this with distinct. I'm telling you, this is what I wanted. I only wanted to know this. It was not by chance. I should really never use union alone. Always use union or, and then use distinct when this is what I want. And here's one where this really starts to matter. So I've got this query here. What I want to do is I want to compute the sum for every person of their transactions from both banks. And here I've written this with union because, well, I'm playing that don't know about this union all, I don't really understand things. So you see, select name quantity from East transaction, union, select name quantity from West transaction, name sum. And look how what I run when I do this. And I'm going to put this to full screen so we can see all the results, all the data at once. Look at here at Adam. It says here the total was 34, but Adam 20, 20, and 14. Wait a minute, that's wrong. His total is 54. Now Ben has 12, and that's all right. He only has 12. Pat 43. Let's see, Pat 12, 12, and 31. Oh no, that's wrong. That's definitely 55. Sue's 19. That's right. And Tina 10. Now we know that Tina has 20. So this is, and what happened, of course, was that when I run this query, the duplicates was removed, and I got it. Well, the result set is some sort of, I don't know how to describe this. Of the distinct quantities, it doesn't really make any sense. Here, I really need to use union or to get the correct results. Now you see Adam has 54, Pat has 55, Tina has 20, and that makes more sense. So let's summarize this on our slides. So union and union all, they combine the result set of 2 more queries into a single result set. And the column names, they are taken from the first query. The order by can only be at the end, and it applies to the full union query. And here in this example, I only had 2, but you can have 5, 6, 10. It's quite powerful, I'm telling you. And you will probably, most of you have used this in some application at some point. Union remove duplicates rows from the result sets, including duplicates within the sets. And checking for duplicates comes with a cost in performance. So you really don't want to do this unless you really have to. And here is the advantage of union all. It does not retain duplicates. And I'm telling you this, you should always use union all, because that is what you want 95% of the time. Because most of the time you don't want any time being spent on removing duplicates for one reason or another. And in a few cases you really want this, wrap the union all in and out to select distinct to make it clear what you're doing. Now I'm going to talk about derived tables. And we did see one example of this. So let's talk a little more about this. So yes, we can do this. Rather than saying a table review after from, we can put a query here in parentheses. This is quite powerful. And this is known as a derived table. This query here is completely independent from the rest of the query. In the difference to the exists we saw before, which is correlated or should be correlated to the rest of the query, this one cannot refer to anything else in the rest of the query. It stands completely on its own. Also, there must be an alias, even if we don't use it. So if I try to run this, I get a syntax error. I need to include the U as well, even if I don't use it. I'm going to move over to another database here to demonstrate this a little more. It's called Northgale. This is a, well, an order database, still a demo database, but it's a little more sensible. It has 1 million orders in it. It's an inflated version of a database called Northwind from Microsoft, a fairly old one, which explains the date you're going to see here, down here from 97. Excuse me. So what I'm going to do here, I want to return some information about customers, sorry, and the orders on a particular day. So I got from the orders table, joined that to the customers table, and then I joined this to this derived table, which what it does logically, it computes the sum of every order in the database. Every order in the database. And then I join that to my orders table. And then I say, I only want this for a particular date in April 97. You might think that this is going to be slow because 1 million orders, that is going to take a long time. And look what happens when I run this query. The response is instant to return 264 rows. Why did this happen? Well, keep this in mind. SQL is a declarative language. This means that we express with our select statement what result we want. We are not writing instructions. Go read this, go read this, go read this, like an imperative language like C# or Java. No. Instead, the optimizer goes to figure out what is the best query plan, and it realizes, hey, wait a minute, I can find the orders on this date because there is an index, and then I only need to compute these sums here for this for these 264 orders, not all the 1 million. So this is a lot faster. And again, just to repeat here what I said before, so this query here, I can't join to orders, or rather, I can't join to this orders in here. I can join to orders, of course, again, but then it will have to be a new instance of orders within this query, because this query is completely isolated from the rest of the query. So a derived table, it's an independent subquery that you can use in from or join, and it cannot refer to anything in the outer query, and it must always have an alias. It is a logical construct and may not be computed as such if the optimizer decides to recast the computation order. It's just a logical thing. And this is a very handy way to reuse a smaller query in a bigger query. So it's very powerful to build complex queries. And then we want to talk about common table expressions that I can see them. They're using them, but they don't really understand exactly how they work. So let's see if I can help you to sort this out. So here I got a similar query to the one above. As a matter of fact, it's very similar. The difference is now it says with order amounts as, then I got the same subquery as above. And then I use this name order amounts down here. But apart from that, it's actually the same query. As a matter of fact, when SQL Server first passes this query, it just sees this as a macro definition. So it's going to take this name order amounts. Okay, it's going to replace this with this query. So we get the query up here. It's the same query. It just, the only difference is that now this derived table has a name. And when I run this, it's fast. I get back quick response. So a CT, on the top of the query, you can define one or more CTs, so-called common table expressions. That's just the name. And for this example, I only had one because I couldn't think of an example good, simple enough to have more than one. But here's just an outline of how you would use more of them. So you say with CT for the first one, CT as parentheses query, comma, right parentheses, comma, the next name as parentheses query, closing parentheses, and so on. And this CT2, well, it can refer to CT1 or it can be completely independent. It's actually not uncommon that you are writing a couple of CTs that are refinements of each other, so that for one reason or another. So, and the first CT is introduced by this keyword with, and here's a thing about those semicolons. You see, I got a semicolon in front. Why? Well, as I told you before, we should always terminate our statements with semicolon in DSQL, but it's not mandatory. It's deprecated not to do so. But there are a few situations where you need to have a semicolon before the next statement, because else the parser cannot sort it out. And this is one of the cases. Here the semicolon is required because those those situations are quite few. I will have to admit, when I write code myself, I don't really use the semicolon very much. So I tend to put the semicolon before with, so not to run into problems. But that's a matter of taste. But you don't have to do that. But if you're a good person and always have semicolons at the end of your SQL statements, you don't need to worry. CTE, what it is it's an independent query with a name. So you can use that name in the rest of the query, including subsequent CTEs. So CTE2 can refer to CTE1, but it doesn't have to. And you use that name just like it was a table. And for each occurrence of the name, the text of the CTE is expanded into the query, which, by the way, is the same thing how views works. A view's definition is also expanded into the query. It's also just a macro. And well, CTE is simply a derived table with a name. That's the only difference. So it's a logical construct. The optimizer will recast the computation order, and the CTE as such may never be computed. Or it may be, because there's no other way for the optimizer to figure it out, or it's the best way to do it, but it does not have to be. And CTEs are really great tools to structure complex queries, maybe even better than derived tables, because if you need to have them in several layers, well, on CTE you can put them on top of each other, whereas with derived tables you will have to nest them inside, and the code might go down diagonally, downwards. It would be difficult to read. But which one to use, it's a matter of taste. And also the scope of the CTE, it's a single query. You cannot define the CTE in one query and then try to use it in the next query as well. It would be great if we could do something like that. I would love that feature, but we can't do that. In that case, we need to redefine the CTE. But as I said, it's a logical construct, so there is no cost in terms of performance of doing so. Now, temp tables and table variables. Well, let's continue in the script that we had. But now we're doing all the same thing again, but slightly different now. We're having this table called hash order amounts. Now, if you create the table with what starts with a single hash mark, that table is private to your process. Most people might be aware of this, but I like to call this out. It's private to your process. If another process can also create a table with the same name at the same time, but behind the covers, SQL Server will add some long suffix to the table, so they are actually distinct from each other. So it's only your own process that can see this table. This is a great tool when you're making complex operations where you really need partial results and you can work with it. It's really powerful. So anyway, I'm creating my temp table, and then I'm inserting into this order amount the same subquery as before, the computation of all orders. And then I use my temp table down here. Now, is this the same thing as the CT? Let's look now what happens when I run this. And you may notice there is a delay. It's still running, and it completes in, interesting, 8 seconds. It usually takes 5. But this time it took 8 seconds. So this time, no, there was no optimization, because optimization in SQL Server is only per statement. There is nothing that looks across statements that says, wait a minute, I don't need to do this. I could just make some logical thing here. But no, this time it's really physical. I'm really telling SQL Server, please stick the sum of all orders into this temp table. And of course, that takes time. There is also something called table variables. It's more or less the same thing, but the syntax is slightly different. I say declare at order amount table, order ID amount, and then insert at order amounts, and then use that name. So, and this is also private to the process. It is just a declared variable, but it's more or less the same thing. Again, if another process says declare at order amounts, that will be a different table. So does this also take time to run? Yes, it does take time to run. You can notice this. We have to wait a little bit. We see results coming, but wait a minute, the query is still running. So this is even slower. Let's see how long time this takes. Yeah, it took 19 seconds. So this was even slower. Oh, let's go back to the slides and summarize this. So temp tables, you use create table, name starts with a single hash mark. You can also use a double hash mark. Those are global temp tables. I have just one piece of advice about them. Don't use them. They are not very useful at all, actually. And table variables, you say declare at tvar table. So slightly different syntax, and they say the same purpose. A working area that is private to the process and not visible to other processes. So you can use this, because sometimes you need to do complex things where you need to compute intermediate results, etc. And two processes can create temp tables or declare table variables with the same name, and there's no conflict. It's really, really great. And when you define a temp table or a table variable inside the procedure, they will go away when the procedure exits. So far, they are all the same. But here, if we create them on top level, that is a different thing. If you create a temp table on top level, well, that is directly in the query window, for example, it will go away when you close that window or you say drop table. A table variable only lives for the single batch, so just like any other variable. And if you talking about nesting, so if you have an outer procedure where you create the temp table and you call it inner procedure, well, that inner procedure can access that temp table, but with a table variable, that is not possible. And both of them live in temp to be. There are some differences in how they're implemented, particularly with regards to logging, but it's not important to know. There is one myth about table variables I like to call out, and that some people believe that they're memory only. That is not true. They are backed up by disk in temp to be, and they will more or less take up the same resources in terms of I/O. Not really. Table variables with have slightly less load on temp to be, because it's slightly less load. But sorry, when it comes to performance, table variables, we saw here the table variable was slower than the temp table. That is not an occasion. Table variables certainly does have a bad reputation to be prone to bad performance. To that end, I would like to give you this tip. If you find that you have a query that's running slow and it uses table variable, well, just as a first thing, without making further investigation, try to replace it with a temp table. It could help. I'm not saying it's always going to do this. The problem might be elsewhere, but it's kind of 90-10 division, that 90% of the time the temp table is faster than the table variable. The full story is a lot more complicated, and there are situations where the table variable gives better performance. But if you want some sort of rule of thumb when to use a table variable or a temp table, so table variables are okay if you only expect a handful of rows. For example, if I set up a table but I'm just going to have some mapping which is constant, they're going to use that in my store procedure, I will use a table variable. But if I expect millions of rows, a temp table, because that is going to perform better. Why it is so, that's for reasons which is so beyond the scope or beyond the level of this presentation. Now, CTEs and temp tables, that's a question I always see. Should I use a CT? Should I use a temp table? Which is faster? Well, we saw in this particular example, the CT and the derived table was a lot faster, because with the temp table, we had to compute the full intermediate result. It has to be computed and materialized. Also, right into disk means that it takes time. So the simple answer would be CT is faster. But oh, no. That is not always the case. This is a lot more complex, because let's say the CT is very convoluted or complex, and then the optimizer will more or less have to compute the full CT, and now it has less information about what will be the outcome. So the rest of the query is not optimized very well. So it often helps, in this case, to store partial results in the temp table to help it to make it easier, or to help the optimizer for the rest of the query. And these are not any simple things at all. Absolutely not. These can be quite difficult even for an experienced programmer to get right with what is the best trade-off, when to use a CT and when to use a temp table. But I like to call out, for example, if you stack 8 CTs on top of each other in one single query, I don't think you're doing it right. Because if nothing else, if you are using a temp table along the way, that also makes your debugging easy. So you can inspect your intermediate results, so you can see whether you actually got the right results or not. And it seems that I'm out of time, so I'm just going to create my very quick summary. Go, what I talked about, Go is not an SQL statement, and it's a batch separation. Null, it's an unknown value. All comparisons with null yield unknown. Use is not null to check for null values, and not in will not give in results with null values. Use not exists to avoid this trap. And not exists is also good for multi-column conditions. SQL is a statically typed language. Many implicit conversions are permitted. They follow a precedence list that defines which type they wins. Union all permits you to combine 2 more results into a single one, and union all remove duplicates. Union all does not. And I recommend you to always use union all wrap distinct to make it clear that this is what you want. And CTEs and derived tables are logical tools to build complex queries. and they're necessarily not computed as such. They are logical things. But whereas temp tables and private table variables are private work areas, and when you stick results in them, they are actually done that physically. And temp tables often performs better than table variables, particularly if you have large amounts of data. And CTE and derived tables are generally faster than temp tables, but the exceptions are commonplace. So that was my part that I have to talk about. Here's my name, my email address, and you find slides and script on that site. Here's also links. They are included in the download for building the databases. And to build Northgate, you need to run 2 scripts. So I'll leave it over to Alex.
Hi there, thank you very much. Thank you very much. If anybody has any questions or any thoughts or any feedback about that, anything that you'd like to say to Erland, any thanks or anything, do see if you can find the questions window in GoToMeeting and add your questions or anything you'd like to say to Erland, add it in there, and I'll go through and I'll read those out and pose those to Erland. We had a few during the session, but they were mostly logistical things. So, for example, there's a question about is this going to be recorded? Yes, it is. We are recording this, and we will be sharing videos afterwards. Stu, do you want to comment about where those are going to be shared or when they're going to be shared? Stu, we can't hear you again.
Stu needs to learn sign language, I think.
Nope.
Nope.
Sorry, mate.
Alex, I had a question while we're waiting, if I may.
Oh, go ahead. Who's speaking? Who's that?
Sorry, this is Richard Swinbank.
Hey, Richard. Cool.
Hi there.
What's the question?
So I was really interested in the stuff around static v dynamic typing, and I think if you're coming at this from a sort of traditional programming language background, it's sometimes difficult to see the difference because you don't see the separation between compilation and runtime things happening, because all of that kind of happens on the server for you. So would you, just in terms of typing, would you call some of these types, would you call SQL types a strongly typed language then, I guess, as well, or no? I'm just curious, really.
Oh, yeah, that's... then I would have to look up the definition of strongly typed. It's statically typed. I would say strongly typed language, I wouldn't expect implicit conversions between strings and integers. So, but it's certainly not dynamically typed like Python or Perl. But as you said, it's a good point, because since you basically, it's a bit compile and go. Well, if you try to create a procedure where you have where there is no implicit conversion, you will get an error. And then I have a slightly longer version of this presentation that I'm actually doing on Data Weekender on Saturday, where I will have an example of this. But I had to cut down some stuff since I only had 50 minutes, which makes this a little more apparent. But it's a good point, though, that if you're only submitting a query, you can't really tell, is this a runtime error or is this a compilation error?
Thanks very much.
We've got a question that's just come in from Sanjay. He said, how long are the temp tables available for? When do they get deleted? Is it when you close Management Studio?
Yeah, so as I said, if you create the temp table in the procedure, it goes away. I should say logically, the physical story is a little more complex, because actually, matter of fact, SQL Server actually caches the definition, but that's, we don't really have to bother about. But that's only for efficiency. But logically, it goes away when you exit the procedure. And if you create it in the query window, it will go away when the session disconnects, typically when you close the window. But if you would have an error like, well, if you run into an internal error which closes the connection, the temp table will also go away. So it's one thing, if you're actually saving data you actually want to keep for a little longer, the temp table is maybe not what you should use. It has burnt me a few times, but not very often, but sometimes. But they will be around as long as the query window is open. But if you close the window, or you connect that window to some other server or whatever, the temp table will go away automatically.
Okay, I think that's all of the questions we've got about the content. We've got a couple of nice comments here, Erland. Tom says, thanks, enjoyed your explanations, learned a few things. Wim says, I'm currently giving a SQL course for beginners to a colleague. You gave me some good ideas. Thank you. So thank you very much, Erland. I think everybody enjoyed that. I certainly learned a few things. Thank you very much, Erland. Oh, there was one other thing. The slides. Somebody asked, will you be sharing your slides afterwards?
Yes. So that's, there we have them. sommarskog.e/. You go to my website, sommarskog.se/%. If you read, well, on the top of the, if you only go to sommarskog.se and read the introduction on the top, there's also a link. You go through the text. My website is not known. Well, my website is very much Web 1.0. I focus on the contents, not so much on the design. And I would also like to extend a thanks to, well, for everyone who's listening. I will extend a thanks to Stuart and Matt and everyone else who's helping with this, and also to Grant and Andrew, who's got up very early in the morning because they're sitting on the left side of the pond to arrange this. Big thanks, and also big thanks to Redgate for providing the infrastructure for this. And I hope everyone will enjoy the rest of the day. And I will just, or if I've already been deprived of my sharing. Okay, that's good.
Okay, fantastic. Fantastic. Thank you very, very much, Erland.